This is Precalculus, section 7.4. We're going to be talking about inverse trigonometric functions. So if you can recall from algebra, a one-to-one function is a function where for every y value there is only one x value that outputs that y value. We also know that only one-to-one functions are functions that have inverses. So a trig function is not one-to-one because its graph does not pass the horizontal line test. Since it does not pass the horizontal line test, we must restrict the domain on the trig functions so its inverse can exist. Looking at the sine curve, we have a point at negative pi, and sine of negative pi is 0. We have a point at negative pi over 2, and sine of negative pi over 2 is negative 1. Sine of 0 is 0. Sine of positive pi over 2 is positive 1. And then sine of pi is 0. So looking at this, if we start from a y value of negative 1 and go up to a y value of positive 1, if we continue graphing this, we won't pass the horizontal, or our function will not pass the horizontal line test. So we need to restrict our domain to negative pi over 2 to positive pi over 2. So our domain will be restricted from negative pi over 2 to positive pi over 2. And our range goes from negative 1 to positive 1. And the reason for that is because if we continued tracing our graph, we would be doubling up on our x values, and then we wouldn't have a function. So the inverse sine curve is just switching our x and y values. So our range becomes our domain, and our domain becomes our range. So the domain for the inverse sine curve, which is also called arc sine, would be negative 1 is less than or equal to x is less than or equal to positive 1, and the range would be negative pi over 2 is less than or equal to y is less than or equal to positive pi over 2. And that's just because our x and y values get switched. So on our x-axis, we'll go from negative 1 to positive 1, and on our y-axis, we'll go from negative pi over 2 to positive pi over 2. So our points will just be flip-flopped. We'll still have a point at 0, 0, but instead of having a point at negative pi over 2, negative 1, we'll have a point at negative 1, negative pi over 2, and we'll have a point at positive 1, positive pi over 2. So this is what our inverse sine graph or arc sine graph curve looks like. Looking at our cosine curve, we know that when theta is negative pi, cosine of negative pi is negative 1. When theta is negative pi over 2, we have a cosine value of 0. At 0, cosine of 0 is 1. And at positive pi over 2, cosine is 0. And then finally at pi, we have a cosine value of negative 1. So looking at our curve, if we start up top, when our y value is 1, and continue down our curve, and stop at the bottom, we need to stop at the bottom because if we continue on our graph in either direction, the inverse of our cosine curve will not be a function because it won't pass the horizontal line test. So therefore, we need to restrict our domain from 0 to pi. So our domain will be restricted from 0 to pi, which means our range ranges from negative 1 to positive 1. Thinking of the inverse cosine curve, which is also referred to as arc cosine, our domain and range values are just going to be flip-flopped again. They're going to switch. So our range will go from 0 to pi, and then our domain will range from from -1 to +1. So on our x-axis, we'll go from -1 to +1, and on our y-axis, we will go from 0 up to pi. So I'll label a point at pi/2 as well. So now plotting points. Instead of having a point at 0, 1, we'll have a point at 1, 0. We'll have a point at 0, pi/2, and we'll also have a point at -1, pi. So connecting these points gives us our inverse cosine curve. Now our inverse cosine curve is in, thinking of the which quadrant it would be in the unit circle. Inverse cosine curve will be in quadrant 1 and quadrant 2. Because we need negative values and positive values, and since cosine is negative in the second quadrant, that's why we use quadrant 1 and 2. Going back to thinking of the sine curve, the inverse sine curve will be in quadrant 1 and quadrant 4, because we need a positive and we need a negative, and sine is negative in quadrant 4. So this is what our sine and cosine, or arc sine and arc cosine curves look like. So moving on to the tangent curve. Speaking of tangent, when we have a theta of -pi/2, tangent is undefined at that point. When theta is -pi/4, our tangent value is -1. Tangent of 0 is 0. Tangent of +pi/4 is +1. And at +pi/2, tangent is also undefined. So we have asymptotes at -pi/2 to +pi/2. So thinking of the curve that we will be using, it's just going to be one period of the tangent curve. So our domain will be restricted from -pi/2 to +pi/2. And our range, since our tangent curve has arrows and they go on forever, our range will be -infinity to +infinity. Or you can also write all reals. Now thinking of what our inverse tangent curve would look like, which inverse tangent is also called arctan, or arctangent. Our domain and range will once again switch. So our domain will now be -infinity to +infinity, or x is all reals. And our range will become -pi/2, less than or equal to y, is less than or equal to +pi/2. So on our x-axis, we will label point -1 and label a point +1. And on our y-axis, we just need -pi/2 and +pi/2 labeled. And at -pi/2, we're going to have an asymptote, and at +pi/2, we're going to have an asymptote. But notice these are horizontal asymptotes opposed to vertical asymptotes. So now we will still have a point at 0, 0. But now we're going to have a point at negative, we're going to have a point halfway between, so at negative pi over 4, so negative 1, negative pi over 4, and positive 1, pi over 4. So just halfway in between the asymptote and the x-axis. So this is what our arctangent curve looks like. So now thinking about the unit circle, we know that we need a quadrant where tangent is positive and a quadrant where tangent is negative. So arctangent is in quadrant 1 and quadrant 4 of the unit circle. Similar to sine. So tangent and sine are similar in this, or the arctangent and arc sine are similar in the sense that they are both in quadrants 1 and 4 of the unit circle. Looking at our examples, it asks us to find the exact value of each expression if it is defined. Exact value tells us we cannot use a calculator, and we just need to use our brains and the idea of the unit circle. It says, remember, the domains of the inverse trig functions are restricted. Remember, sine is just in quadrants 1 and quadrant 4. Cosine is in quadrants 1 and quadrant 2. And tangent is in quadrant 1 and quadrant 4. So thinking of sine inverse as square root of 3 over 2, we can ask ourselves, what angle has sine of square root of 3 over 2? We know that that pi over 3, or 60 degrees, so sine of pi over 3, or sine of 60 degrees equals the square root of 3 over 2. Since 60 degrees and pi over 3 is in quadrant 1, we know that that's an okay answer. So we can kind of give ourselves a check. We know number 1 is correct. Number 2 asks us the cosine inverse of 1/2. So we can ask ourselves, what angle has cosine of 1/2? This answer again is pi over 3 or 60 degrees. We can ask ourselves, is pi over 3 or 60 degrees in quadrant 1 or quadrant 2? Yes, it's in quadrant 1, so that we can check ourselves off. We know number 2 is correct as well. And then finally, for number 3, we have tangent inverse of positive 1. It says what angle, so we can ask ourselves, what angle has tangent of 1? This, the angle that has tangent of 1 is either pi over 4 or 45 degrees, however you'd like to write it. And we just need to check the domain. Since pi over 4 and 45 degrees is in quadrant 1, can check that off. So we did not have to worry about any domain restrictions in this set. For our next example, it says, use a calculator to find an approximate value correct to 5 decimal places if it is defined. So if we type in sine inverse of 0.13453, which is, it's important to make sure that your calculator is in radian mode because you are not given any degrees. You should get an answer of 0.13494. When we type in cosine inverse of 1.2378, you should get an error message. This is because cosine inverse is undefined at this point. And that's because we have a value that's greater than 1. Cosine inverse cannot be greater than 1. So anytime you have a cosine value, or you're taking the cosine inverse of a value that's greater than 1, you can always write undefined.